So now how about uniform cost search criteria? So uniform cost search is guided by the path cost rather than the depth of the search, which makes the complexity calculation a little bit is less trivial than the regular BFS. So first of all, is it complete? Yes, it is, assuming that the solution has a finite cost. The problem would be complete. So how about the time complexity? So remember, for BFS, we had a time complexity of which is a big O of b to the d, where b is the branching factor and d is the depth of the solution. So typically we have the search space, it's a search tree, and we have the solution at assignable level d. And breadth first search, again, will do a level-wise search until it actually reach the level d where the solution is. Uniform cost search will not really do it in such a level-wise. It's going to be a little bit kind of drag because it's going to locate, it's going to still do some kind of, but it's going to be until it reaches the level of the solution D. Actually, here, how can we define D? D is not really defined as a specific level because we are going to move to the search space based on different costs. So we're going to estimate it. And the way to estimate it is, first of all, let's suppose that C star is actually the cost of the optimal solution. So the optimal solution would really have some, let's say, number of kilometers. We suppose also that the action cost, each action cost is bounded. So we have every action would cost at least epsilon. Yeah, given C star and epsilon, we could estimate the effective depth, which is roughly C star divided by epsilon. We need actually to, here the idea is to be able to estimate, instead of D, we're going to have C star divided by epsilon, which is an estimation of the depth of the solution based on our search based on the costs. Okay, so in this case, instead of big O of B to the D, we're going to have a cost of, in this case, of B to the C star divided by epsilon. So this will be, this is just based on what we estimated as the depth of the solution given this strategy. Similarly, we also estimate the space complexity using this estimation of the depth of the search. So for space complexity in the regular BFS, we had also B to the D. The D now is also replaced by C star divided by epsilon, which represent our estimation of the depth. Is the solution optimal? Yes, it is. It's going to really search for all the costs until it finds the least cost path if there is a solution. Okay, so implementation, as we said, it's also a queue, just like BFS, but it's, in this case, what we call a priority queue that is ordered by the path cost based on the cost function g of n, which is the lowest first, which is actually implemented as a heap. Okay, so that was for the complexity. So uniform cost search has great features that it is complete and optimal. However, it also explores the space in every direction because no information about the goal is provided. So we are prioritizing this in this case not by depth but by cost, which means that suppose we have a start state here and the goal is here. What will happen is that the search will go around the start by, let's say, for the map, increasing the length of the radius. So we're going to look around and around. So the search will be really exploring the area and going bigger and bigger in terms of the search until we hit the goal G. So you could see that that's really a waste of resources, a waste of time in searching around the start space. And we would love to really use some information about the goal in order to go really straighter to this goal rather than exploring and wasting time looking around based on the cost.